Welcome to all. Now we will discuss a very important concept, that is diodes and their bias in UGC-NET, GATE, APRCET, DRDO, Bell and other competitive exams. First we will discuss the PN junction diode. PN junction diode works in the forward bias condition. In reverse bias you are not getting any current. Okay, so diode works in the forward bias. So coming to the Zener diode, for Zener diode, in forward bias it acts like a PN junction diode, but in reverse bias due to the breakdown voltage you will be getting the current in reverse bias. Okay, so Zener diode works under the reverse bias. If it is forward bias, it is same as the PN junction diode. Coming to tunnel diode, it acts in the forward bias. It operates in forward bias. Varactor diode operates in reverse bias. Photodiode operates in reverse bias. Avalanche photodiode works in reverse bias. PIN diode works in forward bias. LED light emitting diode works in the forward bias. Solar cell, you should be very careful for solar cell. In some exams, if it is in dark mode, it is operating in forward bias. Okay, solar cell in forward bias is similar to the PN junction diode, but the actual bias for the solar cell is the reverse bias. Why? Because it acts as a photodiode in reverse bias. And you can remember, for solar cell it mainly works in the reverse bias. Okay, but only in the dark mode it is forward bias, which is similar to the PN junction diode. So coming to the laser, it works on the forward bias. Coming to PIN photodiode and JFET, it works in the reverse bias. Now we will discuss one by one deeply the each and every diode, which covers all the MCQs in the competitive exams. Okay. Now we will discuss first diode, that is Zener diode. The symbol for this Zener diode is this one, and the VI characteristics of Zener diode. You will be having the breakdown voltage if it is a BZ 5.1 series. If it is BZ 5.1 series, across 5.1 you will get the constant voltage. Okay, at this 5.1 ohm you will get the constant voltage. So for this it works in the reverse bias. So the best choice of silicon ICs. Okay, it is the best choice of silicon ICs rather than germanium. It is a non-linear device, and a Zener diode has a sharp breakdown voltage, and it is used as voltage reference and heavily doped. In Zener diode, both P and N regions are heavily doped. Zener diode characteristics are very close to that of ideal voltage source. Okay, this is very close to the ideal voltage source characteristics. And Zener diode, when used in voltage stabilization circuit, is biased in reverse breakdown voltage. Okay, these all are the common points which works in the reverse bias. It is preferred for DC coupling. It is one of the important MCQ you can expect. And coming to very important one, the impurity concentration is 1 part in 10 power 5. For ordinary diode, 10 power 8, means for 1 part you need to dope it for 10 power 5, and for ordinary it is a 10 power 8. Okay, which is more. If coming to the impurity concentration, 10 power 5 is enough for the impurity concentration. For tunnel diode, it will be still decreasing. Zener diode works on the principle of tunneling of charge carriers across the junction. So you may ask the question, Zener diode works on the which principle? Means tunneling of the charge carriers across the junction. Okay, it is very important. And if diode is heavily doped, the electric field produced is about how much? It is 10 power 7 volt per meter, and it is a low frequency rectifier. These all are the MCQs which were asked in the previous question papers. If you remember all these points, in these points only you will get the Zener diode concept. Okay, now we will discuss about the tunnel diode. Tunnel diode works in the forward bias condition. This is the symbol for tunnel diode. You need to remember these symbols. You may ask the match the following like questions. Okay, and coming to the characteristics, it is increasing from the negative slope to the slowly increasing, and you will be getting the constant at the voltage side. And this is the characteristics of the tunnel diode. And tunnel diode has highly doped p and n regions compared to the Zener and p-n junction, and it degenerates p and n material, and it exhibits the negative resistance characteristics. Why? Because the characteristics are starting from the negative side. So you may ask which diode exhibits negative resistance characteristics, means the answer is tunnel diode. And it acts as a excellent conductor in reverse direction, and it acts as a very high speed switch and high frequency oscillator. This is a very important question. Which diode act as a high speed switch and high frequency oscillator, means it is nothing but tunnel diode. It is made with germanium or gallium arsenide. Tunnel diode has zero breakdown voltage and it is heavily doped. And which diode is a fast switching circuit, means it is of the tunnel diode. Okay, and coming to the number of cutoff frequencies, it is also very important MCQ. Tunnel diode has two number of cutoff frequencies. Okay, and one of the application, tunnel diode is used as microwave generator. Okay, tunnel diode is used as microwave generator, high speed switch and high frequency oscillator. Remember, these are the applications of the tunnel diode. From applications, these are the questions asked from the different competitive exams. And coming to the next point, it is a voltage controlled negative resistance, and it is best suited for amplifier. This is also an application, and the values of the voltage VD across tunnel diode corresponding to peak and voltage currents are VP and VP. Means this is the range you should remember. VP is far less than VD, less than VV. This is the condition you need to remember for MCQ. Okay, and coming to disadvantages, it is having low output voltage swing, and it is a two terminal device. Due to this isolation between input and output leads to serious circuit design difficulties. Okay, so these are about the tunnel diode. These all are the points which I have taken from the previous papers during my preparation. So diodes concept plays a very important role, and next in our next video I will discuss the Varactor diodes and remaining diodes. Thank you so much.